Hi everyone, welcome back to yet another Euphoria Academia YouTube video, where we do past papers and show you tips and tricks on how you can tackle the papers. Today we're going to be doing the Physical Sciences Paper 1, 2022, which was written in the year 2022 in the May-June exam period. So my name is Ole and I'll be taking you through it, so let's get to it. Okay, so we're going to be looking at question 3. All right, now question 3 runs from 3.1 all the way to 3.4 and it holds a maximum of 20 marks. Now, question 3 is actually about projectile motion, right? So we're told that a small disk C is thrown vertically upwards at a speed of 15 meters per second from the edge of the roof of a building, which has a height of 30 meters. And after 0.5 seconds, a small ball is shot vertically upwards from the foot of the building, so at the ground, in order to hit the disk C. So we already know that at some point, the disk C as well as the ball B are going to clash. They're going to hit into each other. So we probably are going to ask how long it's going to take, what's the height that happens, and all that. But let's get into the question. Okay, so we have a ball on top of the building at 0 seconds, and then this ball will actually be launched at an initial velocity of 15 meters per second, and it's going to reach some maximum height at where it's going to have a velocity of 0 meters per second. At the same instant, we have a second ball, well, not really a second ball, at the bottom, right? Now, after some half a second, it will have an initial velocity of 40 meters per second, while the disk C will be at some height. Now, it will be launched, the ball will be launched at this initial velocity up until it reaches the disk. Now, how long will it take? That is the question. Let's get into it. Now, for question 3.1, we're asked to define or explain the term projectile, right? Which already should tell you that we're talking about free fall and stuff like that. But projectile is an object which has some initial velocity and moves only due to the force of gravity. So that's the only force that acts on it. And that's your answer. All right, for question 3.2.1, we're asked to find the time taken by disk C to reach its maximum height. Now, we know that at the maximum height, our V is going to be 0 meters per second, right? We'll just call that our final V. We are given an initial velocity of 15 meters per second, and we're asked to find the time, right? But it's also important to determine or say which direction you're taking as positive. So in this case, I am going to take up as positive, but our acceleration y is acting downwards, right? And that has a value of 9.8 meters per second squared. All right, so I'm going to use the formula Vf is equal to Vi plus A delta t. Now, we already know that we're moving from t is equal to 0 to some time t, all right? So I'm just going to replace the delta, which is t. All right, so let's just do some substitutions. VF is 0, as stated before. Our VI is 15. It's positive since it's directed upwards, and our acceleration is acting downwards, so this is going to be negative 9.8 multiplied to t. Now, doing some algebra, we're going to find that our t is equal to 1.53 seconds. And that's our answer for 3.2.1. Right, so next question is question 3.2.2, and we are asked to find the maximum height above the ground, right? Keyword on above the ground, all right? So we've already determined the time it's taking this thing to reach the maximum height, right? And let's just find the distance from the top of the building to that maximum height. Right, we'll call that HI. Let's call it HI. All right. So we're going to use the equation VF squared is equal to VI squared plus 2A delta Y, right? And I'm still taking up as positive. We're just going to substitute. So at this maximum height, we know that our VF is 0, our VI is 15, and it is positive, actually. 15 squared plus 2. Now, acceleration is acting downwards. So this is going to be negative 9.8, and that is going to be multiplied to delta y. But I already know that we're moving from 0 to some height hi, and in this direction, this y is going to be positive, and because we have a 0 there, I'm just going to find hi. All right, so let's just substitute things properly, because I want to show you exactly what I mean. 1.8. So we're just finding hi, that hi. All right. Now, after doing some algebra, we're going to see that our hi is equal to 11.48 meters. And this is going to be from the top of the roof. Top of roof. All right. So total height above the ground has to take into account the 30 meters of the building height. So it's going to be 30 meters plus our hi, which is 11.48 meters, and that is going to give us a total of 41.48 meters above the ground. All right, for question 3.3, let me just get that. Question 3.3, we're asked to calculate the time from the moment that this C was thrown upwards until the time ball B hits the disc, right? So we know that after 0.5 seconds, ball B is shot, right? But where is disc C at 0.5 seconds? And what is its velocity? What its velocity? These are the questions that we need to ask ourselves before we can talk about exactly how to solve these and stuff like that. All right, so let us see, right? So the distance, or let's just say that the displacement of C after 0.5 seconds can be found as VI multiplied to our delta T plus our half acceleration multiplied by the square of our delta T. Now I'm still taking up as positive, right? And we know that our acceleration acts downwards. Our T, well, essentially in this frame, we're moving from 0 to 0.5 seconds. All right, so I'm just going to drop the delta because it's not going to affect it that much. All right, so let's find the distance. All right, now our VI is given as 15 multiplied to our 0.5 seconds plus half of our acceleration, which is negative 9.8, and we have to square our 0.5 seconds, and after some calculator punching, we find that our distance or displacement is 6.275 meters. This is for above the roof. All right. Now, what is the height above the ground? All right, height above the ground at this instant after 0.5 seconds. All right. Well, it's simply our 30 meters, the height of the building, plus our distance that we just calculated, which is 6.275 meters, and that is going to give us 36.275 meters. Right, now it's important to note the distinction here, right? So we just said that this is our delta y of the disk C, and this is our, actually this would be our delta y of B. This is what B needs to cover to get at least above the roof of the building, right? Or yeah, delta of the building, because the ball B is moving from the ground going all the way up. All right, now that we've distinguished that, well, essentially we need to understand what this distance actually means. Now this distance, as stated before, is the distance, the height of the building plus the distance traveled of the disk C after 0.5 seconds. But what does it actually mean? Now, this means that this is essentially the distance ball B has to travel to meet disk C. All right, this is like the distance the ball has to close down in order to hit the disk. You have to close down B. Now the question that arises is, how long will it take to close down this distance, you know? And yeah, that's essentially what we're trying to find in this question. Okay, so after 0.5 seconds, our initial VI for our disk C is not 15, right? Because of the force of gravity acting downwards, it's actually slowing down this ball. So we need to find out what velocity our disk C actually has, right? And we're still going to use the equations that we have been using. It's just that in this case, our VF is essentially the velocity after traveling 0.5 seconds, right? That's our VF, and that is equal to our VI plus our acceleration multiplied by our delta t, and in this case our delta t is just going to be 0.5 seconds. Our acceleration, we're still taking positive as upwards, acceleration is acting downwards, and our VI is 15, right? So this is going to be 15 multiplied by negative 9.8 multiplied by 0.5, and our velocity of our disk C after 0.5 seconds is actually going to be 10.1 meters per second. All right. Now we have to use simultaneous equations because simultaneous equations give us an indication of these things intersecting, right? Because we will have a common time that these things happen. So when is the intersection is the question. When is the intersection? All right, still continuing with 3.3. So we already know that we have a distance to close down, right? So that distance to close down is actually just our delta YC plus our delta YB. And we've already established what these things are, right? And if we have that, essentially, we're just going to substitute the equations of motions for this guy and for this guy, right? So what do we have? We have our VI multiplied to our delta t plus our half acceleration delta t squared plus let's just write velocity of c to make things clearer, and then plus our velocity of b multiplied to our delta t plus our half a delta t squared. Alright, so let's just talk about what exactly is happening here. So this VC is what we calculated, the velocity of this C at or after 0.5 seconds. Alright, and then this delta t is actually going to be common for all our terms, right? Because we're trying to find out how long it takes. And we actually calculated this in the previous slide, so we're just going to substitute that. But I think let's just simplify things while we have variables. So our delta YC plus our delta YB is actually equal to, we can take out a common factor, or let's just group things. Let's just start off by grouping things, right? So we're going to have delta t being equal to, actually no, that's going to make things a bit complicated for us. I think we can move on to just substitute what our terms are. Alright, so we already calculated what they are. Our VC is 10.1 multiplied by our delta t, this is what we're trying to find, plus our half. Now acceleration is still pointing downwards, and it's 9.8 delta t squared. That is going to be added to our initial velocity of our ball, which is 40 delta t plus half of our acceleration, which is 9.8 multiplied to square of delta t. Alright, so let's just substitute what we have in the beginning. So YC plus YB, we already found that to be 36.275, and that is going to be equal to, now something to note, right? So because our disk C, right, is moving from the top of the building from the top of the building and then is shooting up. It's going to come to a point where it reaches the max height, and then it will have to come down. Now at this point, this V is actually going to be pointing downwards, thus making it negative. All right. Now after 0.5 seconds, we still have a velocity pointing upwards, but to account for this, because we're looking at the total time, it might come to a point where after, remember that our max height was reached at 1.23 seconds, something like that. To account for this change of direction, this displacement is actually going to be negative because we're actually slowing down. So yeah, essentially we have a situation where we have that distance that we traversed after 0.5 seconds, which was 6.275. I'm just going to write 6 in this case. That's going to be minus the 30, and that's going to give us a negative. That's essentially the displacement that we're speaking about here. So this displacement is actually negative. So let us account for that there. So this is going to be negative 10.1 delta t plus half of negative 9.8 multiplied to the delta t squared, that is still in the square brackets, plus 40 delta t plus half negative 9.8 delta t squared. All right, cool. So let's just do some algebra before we confuse ourselves. So this negative is going to be applied to this 10.1 as well as this result here, but we have a negative in the negative 9.8, so negative times a negative is a positive, but here negative times positive is going to give us a negative. So it's going to be this guy, let's just call this guy D and this guy F. So it's going to be this term because these terms are the same. All right. So it's essentially going to be D minus F, and that is going to give us 0. So what we're going to be left with is 36.275 being equal to negative 10.1 delta T plus 40 delta T, and that is going to give us a delta T of 1.21 seconds. Apologies, this was not the answer. It will reach the maximum height. The maximum height is actually reached after 1.53 seconds. There we go. 1.53 seconds. Apologies for that. All right, I got confused with this answer here. Okay, but so this is the distance it closes down the disk. All right, but it's not the total time, and we were told to find the total time. So the total time takes into account the before and after 0.5 seconds. So the actual total time, so our delta t total is actually the 0.5 seconds that we have to wait for ball B to be shot up, plus our 1.21 seconds which it takes to reach the C, and our total time is 1.71 seconds. Now question 3.4, we are asked to on the same set of x's, we are meant to sketch the velocity versus time for disk C as well as for ball B from the moment that disk C was thrown upwards until ball B hits the disk. Now we need to indicate a couple of things: the initial velocities, the time at which ball B was shot upward, the time at which disk C reaches its maximum height, and the time at which ball B hits disk C. All right, so obviously you guys are meant to do this neat. I'm just going to quickly sketch it in the interest of time and explanation. So we're going to draw a y-axis, we're going to draw an x-axis, right? And on our y-axis, we're meant to have velocity. So we're going to have velocity on our y-axis. Let me just write it like this. We're going to have velocity and it will be in meters per second. All right. So and then on the x-axis, we're going to have our time and it is measured in seconds. All right. So our key moments of interest, we have 0.5 seconds, and we have the other point, which is the max height, which is 1.22 seconds, and we have another point which is 1.71 seconds. Okay, now our initial velocity, we're going to start with the C. Its initial velocity was given as 15 at time is equal to 0, and then it took 1.3 seconds or 1.22 seconds to reach its maximum height where the velocity was 0. So I'm going to draw a straight line. Now it's a straight line because remember our acceleration is constant and it is pointing downwards, so that's why we have a decreasing function. All right, now at 0.5 seconds, that's when we have the initial velocity for block B, and let's just draw like some dotted lines. All right, so at this point we have an initial velocity of 40, and after 1.71 seconds, it's not going to have a velocity of 0, but that's when it will be caught up with this disk C, right? So essentially we're moving from here to here, and remember I stated that after this 1.22 seconds, the disk, is going to come back. So it has like a parabolic path. So it goes up, reaches its max height, then turns around. All right, that's essentially what's happening with this disk C. All right, so that's why its velocity actually crosses the x-axis to become negative up until it has some velocity. So we don't know how much this velocity is, but it will have some negative velocity at 1.71 seconds. And yeah, this is essentially your graph. Remember to label. So this is our ball B, and this is our ball apologies, not a ball, it is our disk C. All right, obviously you guys are going to have straight lines, but yeah, that's essentially the graph.